Oh, I thought that was black. Whatever, purple works. Okay, so, yeah. So, intro to algebra. All right, so first thing for the order of operations is, it's a little wrong. But just the way people think of it, not that it actually is. So the first thing is, and I would create more space than I'm writing right here, but it actually should look more like this. So it's not please excuse my as in multiplications before division, dear, and as in additions before subtraction, Sally. Actually, addition and subtraction are the same operation, so they come at the same time. Multiplication, division come at the same time, okay? Now actually, those are gonna come up in a little later. I'm gonna spend a little time on parentheses. Because there's a few really common mistakes that come up over and over and over in algebra that we can highlight right here and at least point at them and bring them into the light. And then if they come up once or twice or 10 times on your homework, eventually, painfully, slowly, hopefully you'll learn. Okay, so parentheses. I really got 2 hints for parentheses. Okay, the first is the most important. There are implied parentheses in math that lead to a lot of mistakes for people. And this is that horizontal lines imply parentheses. Okay, and I'll give you a couple examples of this. One example is square root of 9 plus 16. Okay, this horizontal line here absolutely implies that everything under it has to be done before you do the square root. Okay, there are parentheses there. So this is square root of, in parentheses, 9 plus 16, inseparable group. You cannot touch one before you deal with the group. So this is square root of 25 equals 5. Okay? It's absolutely not the square root equal to the square root of 9 plus the square root of 16, which would be 3 plus 4 is 7. Okay? So horizontal lines do imply that there are parentheses. Okay? Another really common example, this is the more common one. Okay, and I brought this up already in the last one, but x plus 3 divided by 3, this horizontal line in the middle implies that everything above and everything below comes as a group. So this is a group, and then this is one term, so it doesn't matter if it's a group. So this is equal to, in parentheses, x plus 3 over 3, which cannot be simplified. It's absolutely not equal to, and you can do x plus 3 over 3, reduce, x plus 1. So definitely not able to cancel one part of this group. And that is by far one of the most common mistakes that will come up over and over and over, especially as things get more complicated and you're stretched to kind of abstract or, make these analogies of, oh, it's just like a simple fraction, but it looks really scary and anxiety causing. Then all of a sudden these foundational skills get tested. You're like, well, now I can cancel an x with a this. No. Anytime there's a horizontal line, it implies that there's parentheses, and that thing on top is absolutely an inseparable block. And kind of something that I'll repeat over and over through the semester is that plus and minus signs actually make life way harder. People think like, nah, I did that in like 2nd grade, it's so easy to add and subtract. Actually, as soon as you make an addition sign or subtraction sign, that separates things into multiple terms, which multiple terms is literally the definition of polynomial, poly meaning many, and nomial meaning term. So polynomial is exactly what happens when you make a plus sign. And dealing with polynomials is so much harder than dealing with monomials, right? So I'll say over and over and over, when there's a plus or minus sign, things are way harder, okay? We'll get to some more examples, okay? The other hint is when there's nested parentheses, Start on the inside and work outwards. In other words, a quick example is something like, I know I'm running out of room here. Okay, so 5 times in parentheses 2 minus 3 plus 2. Okay, you might think, oh, there's round parentheses, there's square parentheses. Those are the exact same thing. The only reason we use square sometimes and we use round sometimes is because it gets confusing if you do 5 times 2 minus 3 times 2 plus 1 parentheses, parentheses minus 2 parentheses, parentheses, 5 plus parentheses, parentheses. Then it's like, well, which round one goes with which round one? So all we do is we say, okay, here's one. The next one we'll make a little bigger and square. And then it becomes a lot more obvious that these go with each other, these go with each other, these go with each other, and then the next one would be even bigger and square. And just visually it becomes simpler to follow what's happening there. But square parentheses and round parentheses are exactly the same. Okay, so here we've got nested parentheses. We've got one inside of another. I don't know if nested parentheses is actually a term, I just make these things up. But you've got a parentheses inside another parentheses, so we start with the inside one. So this would be 5 times 2 minus 5. And then there's only one parentheses, so this becomes 5 times negative 3, which becomes negative 15. Okay? But the single most important skill for algebra is at the end of every problem, you're going to have a bunch of numbers. Can you accurately combine those numbers to give me the answer? Right? If that's where your mistake is, great! That's like the easiest one to fix and spend tons of time on. Right? It's much harder when you're just like, I don't understand this and that and the other. Right? Figure out these mistakes at the very beginning, and let's fix them. Alright, so exponents, there's really only one hint that I've got for you. These only apply to the one thing immediately to their left. Now, to be even more clear, the common mistake I'm specifically avoiding is it does not include the negative sign. Unless there are parentheses. Okay, and you're going to find I go really slow at the beginning. That's because by far the first week is by far the most important stuff. That's why it seems like, this is easy, we should just go quickly. I'm not going to assume you know any of this stuff. I really want to highlight really common mistakes. Alright, so some examples here are negative 2 squared. Okay, if I look at this squared, what is the first thing it immediately hits? Is a parentheses. It does not even matter what's in the parentheses. This is parentheses squared. Okay. Now it happens, it's a negative 2 inside, doesn't matter, whatever. It's negative 2 times negative 2, so it's positive 4. Okay? Whereas, if I have, this is the most common mistake in this area. It's about 4 common mistakes that we'll hit today that are really big. Now, this squared hits the 2. It only squares the 2. The negative sign is not affected. So this is equal to negative 2 times 2, or negative 4. It's totally okay to ask questions. It's totally okay to say why. But, okay, a couple ways to think about this. Okay, one way is this is saying the opposite of, so it's the opposite of 2 squared, so the opposite of 4 is negative 4. Another way to think about this is negative 1 times 2 squared. So this is negative 1 times 2 times 2, or negative 1 times 4, or negative 4. Another way to think about that same thing is, okay, is what if I have 5 minus, whoops, 2 squared, okay? Well, if you say negative 2 squared is positive 4, then wouldn't this become 5 plus 4? That's obviously not right. 5 minus 2 squared is 5 minus 4, right? And a lot of people would get it right in this circumstance, yet for some reason when I do this, they're like, now it's positive 4. Now it's negative 4. Now it's positive 4, right? Like, that hand covering the 5 shouldn't affect it. This negative sign being attached to this 2 squared shouldn't affect it. So I bring that up. It's the same thing. So it's actually correctly like this, which is 1. So that negative sign doesn't get sucked into the exponent. Another way, last way I'll give you, is 3x squared. What is being squared there? Just the x. Somehow some people stuck that coefficient inside. So this is just the x getting squared. So it's 3 times x times x. It is not, this is definitely not equal to 9x squared. 9x squared, 3x squared, totally different things. Because then 9x squared would be 81x squared. Then 81x squared would be 81 squared, whatever that is, x squared. And then that number would get squared infinitely over and over and over, right? That would just be nonsensical. Okay. So the next one's the easiest. But I got a little funny story that goes with it. Okay, so the next one is M and D. So multiplication and division. And my high school math teacher always used to say, there is no such thing as division. There is no such thing as subtraction, because there really isn't. I made this sign up. I don't think it's actually a real sign, but that means N in my weird language. Okay, so multiplication and division. The only hint here is in order from left to right. So, quick example. My story is, I just got my master's in math. I have my master's in education. Went to teach my first class. It was a 6th grade math class. And this was the problem that got asked, and I did it wrong. My 6th grade was like, that's not right. This is how you do it. And I was like, oh, okay, cool. Learn something every day. But it's just 4 divided by 2 times 2. And if I hadn't, given you that hint, right? I mean, what's the natural thing you would have said?
Left, right, 2 times 2.
Yeah, you would have, I mean, you're supposed to go left, right, but naturally I was like, please excuse my dear Aunt Sally. So multiplication comes before division, so this is not how you do it. But I was like, yeah, multiplication comes first, so it's 4 divided by 4 equals 1. But that's not right. You actually go from left to right, so it is 4 divided by 2, which is 2, times 2, so it's actually 4. Okay. Now, in all honesty, this doesn't actually occur that often, and the main reason is we don't use this symbol that much. I mean, you don't see this. Instead, we use a division bar. So if I rewrote this as 4 divided by 2 times 2, then nobody's going to do the thing wrong. Everybody's just going to say, okay, well, this is 4 divided by 4. It's a different problem than if I were to say 4 divided by 2 times 2, right? If I were to say 4 divided by 2, divided by 2, like there's no mistake here. Obviously, 4 divided by 2 comes first, and then you divide it by 2. So that's why, I mean, this and this are totally separate problems, right? And so because instead of using a symbol, we use a division bar, there's no mistaking the 2. This is obviously equal to 1. This is obviously equal to 4 divided by 2 is 2. 2 divided by 2 is 1, right? Yeah.
The way that bottom line, the way you wrote that, wouldn't that be 4 divided by 2 times 2?
That's what I meant to say.
Okay.
Yeah, wait. I did both of them weird. 4 divided by 2 times 2. 4 divided by 2 times 2. That's what I meant to say, right? So these two problems, totally different. As I said, they're both equal 1. So, right, so because we use a division bar, this whole thing doesn't happen that much. I bring it up just because it was embarrassing as a person with 2 master's degrees, one of which being in math, and I was doing crazy proofs and stuff, and then to go to a 6th grade class and be like, oh, I can't do 6th grade math. That was a little embarrassing, but whatever, you gotta admit what you can and can't. But the next one is really a cause of confusion, so this next one is really important. And the next one's addition and subtraction, which sadly, as you guys probably know, negative signs cause you a lot of points on tests and quizzes and so on in your lifetime of mathematics. So addition and subtraction. The easiest way to say it is in order from left to right. That's easy. But this can get pretty tedious. If there's like 10 things to add together, to add the first 2 and then rewrite the other 8, and add the next 2, rewrite the other 7, add the first 2, and just to keep whittling that down takes a lot of time. So instead of doing that, I have a shorter method. I make up weird like acronyms, catchphrases. Let's see how part of you being a middle school teacher. But the one I like to use here is called SMATO, and it saves me from a lot of negative mistakes. And what it means is subtraction means adding the opposite. Okay. And the way I do this is, first I SMATO. So 1, I change all subtraction to adding the opposite. And if you want to use this, great. If not, great. Okay, but this is how, when I make answer keys, this is what I'm doing, this is what my notation is. I found that this prevents the most mistakes. And if I have a choice between method 1, where I'll make 2 mistakes out of 1,000, and method 2, I'll make 4 mistakes out of 1,000, I'm going to choose the safer one. Even if it has an incremental benefit, I'm always going to hedge my bets. Okay? So first we change all the subtractions to adding opposites. So now all we've got is addition. So now I'll collect all my positives, because then it's easy. I'm just adding up a bunch of positive numbers, and I'll do an example. Okay, 3, I'll collect all my negatives. And then 1 time at the end, add my negatives and my positives. Okay, so one of the first questions that you come across in the first test is going to look like this. It's just going to be a big string of addition and subtraction, because it's one of the most important things that I can teach you. So -4 minus 2 minus -3 plus -5 minus 6 minus -1 plus 9. Okay, so I'm just going to put something like that as like problem 1, problem 2 on your first step. Okay, so the way I solve this is I switch everything to adding the opposite. So a quick example here is 5 minus -3 would become an -1 minus 2. Okay, so what would 5 minus -3 become?
5 plus 3.
5 plus positive 3, or 8. And -2 minus 1 would become? Oh, I said that backwards. Well, but yeah, but how would I write it first?
-1 plus.
-1 plus 2.
Plus -2, so we switch adding the opposite, and then it's easy. Oh, I've got a -1, and I've got 2 more negatives now, that's obviously -3. Whereas looking at this, it's like, okay, well, is that -1, or is that -3, like which direction am I going? So an easy way is, it takes like 2 brush strokes. It's 1, 2, 1, 2. So I switch to adding the opposite. Adding the opposite of negative is positive, or adding the opposite of 2 is -2. So over here, my very first step when I do anything like this, and so often the last step in your problem is a bunch of addition and subtraction. So I go, okay, I'm adding the opposite, that's already addition, adding the opposite, that's already addition. Then what I do is I collect all my positive numbers. So I say, okay, that's a negative, here's a positive number, and I include the signs. Okay, because I don't just circle the 3 and forget that it might be negative or positive. I take the signs with it. That's a negative, that's a negative. Oh, here's a positive, here's a positive. So adding those together, 9 and 1 is 10 plus 3. So I got 13 positives. Plus how many negatives? So that's 6 plus 5 is 11, plus that's 17. So I got 17 negatives. And then only one time at the end, so I have to actually subtract. So I go, okay, 13 plus a negative 17, that's subtraction. So that's 4, and there were more, what, negatives or positives? More negatives. So the leftover is negative 4. So that's how I always deal with addition and subtraction, and that to me saves a lot of trouble. The classic mistake, and I fought this girl when I was teaching in Switzerland, like refused to believe me and just continued to get like problems wrong on every quiz. I give weekly quizzes in my class, and every quiz I give the same type of question. Every quiz she would make like 3 mistakes, and it was, what if I write 5 minus 2 plus 3? Right? So she would always say, please excuse my dear Aunt Sally, which is weird because she was a French student, her native tongue was French, but she had some acronym, I'm sure, in French too, but you know, addition comes before subtraction, so she would always go, okay, 2 plus 3, this is 5 minus 5 is 0, which is totally not correct, right? If you do left to right, and all years she did this, it was such a fight, this should be 5 minus 2 is 3, plus 3 is 6. Now you could actually do addition first, because addition and subtraction are the same thing. So really, it doesn't matter what order you go in, as long as you realize that this is a negative. So go plus a negative. Now it doesn't matter what you add together in what order, because it's all addition, right? So now I've got 5 plus a negative 2 plus 3. It doesn't matter, I could add these 2 together and get 1, plus 5 is 6. Or I could add these 2 together and get 3, plus 3 is 6. So order doesn't matter once you've turned into addition. So that's why my high school math teacher would always say, there's no such thing as subtraction, there's no such thing as division. Okay, so, yeah. So that's order of operation. Any questions? No? Okay, good, good. So what we're gonna do now is we're gonna walk over to the MLC, then we're gonna take a little break.